Thanks. Hey, everyone. I'm Rick O'Connor. Some of you might know me from early days in the RISC-V Foundation and then in Open Hardware. This is my last RISC-V event. Florian is taking over my role. I'm going to hang out with my grandson and retire. So if you don't know Florian Wohlrab, you haven't been paying too much attention in the ecosystem. He's been around the RISC-V ecosystem for a while, played a big role in helping Andes in the commercial success of their cores, has been on board now with us for about a month as part of the handoff. And this is my last official RISC-V slide, an Open Hardware slide. So Florian, over to you.
Hey everyone. Hey Rick, wait a moment. Could you please come up for a second? That would be appreciated, man. So yeah, I guess many of you know Rick and we have prepared something for you. Rick has founded RISC-V, he has founded Open Hardware, he has really done a lot of the ecosystem, and the members of Open Hardware, but also the staff, we want to show our appreciation for Rick and present him this plaque. Rick is retiring, but he needs something for his bookshelf to always keep remembering. So thanks for your effort and your hard work, Rick.
Thank you. Thank you.
All right. So today, actually, our topic is lessons learned in the last 3 years from open source cores, especially here. Before I jump into this, I just want to bring up some news. We sent it out this morning on the Business Wire. We are working on some cool project where we are taking our industrial grade open source SystemVerilog cores and put them together in a platform. We make bit streams for FPGA boards, but also for the Amazon F1 FPGA instances. And our motivation here is to provide a vendor-neutral continuous integration software platform. So check it out. I also will come back later. Before I'm going into Open Hardware, I just want to make a short question. Who knows what is Open Hardware? Or who has heard of Open Hardware? Great. That's amazing. That's really good. So that saves me a lot of work. I make it very brief here. Open Hardware, we're a global non-profit organization. Our headquarters is in Canada, but we are really working all over the place. We have members from all over the place. And what we are doing, we are really making this industrial grade open source CPU cores. What you can see here is some of our members. We have over 100 members and partners contributing to this ecosystem. But think about this more of engineers submitting resources. So when you see these logos, you can think about 400 to 500 engineers collaborating together on open source cores, making them better, upstreaming to GitHub, working on the tools and everyone. So I think that is the real thing behind Open Hardware, this huge collaboration from different companies, from different backgrounds, bringing our world to a better place. Academic members joining, they are really happy to get cores which are used in real silicon, taped out, having the chance to apply this. So you see it's also a very good diversity from every region in the world. We got members and continuously expanding this list. Last but not least, our partner ecosystem, also very important for us. Partners contribute a lot to it. And yeah, that is all this thing about Open Hardware, to bring together this ecosystem, these partners, and make something together. Coming to Open Hardware, I want to go a little bit in the past. So Open Hardware in the beginning, when Rick started it in 2019, there was a lot of demand from the market to have open source cores which are available for industrial use. And what we started were from the ETH Zurich, we took the Pulp platform cores, especially the RISC-V and the Ariane, an embedded core and an application class core. And then our founding members, some of them like here, Silicon Labs and Thales joined. They kind of took the helm, the steering wheel, and we made this course, brought them into an industrial environment. So what is really important when you go for this industrial adoption, you need to have a roadmap. And from these 2 cores, we have developed this roadmap. Actually, as of today, we are having 9 something products. There will be more in the future, so we are actively expanding our roadmap, making sure that we are always integrating the latest specification and adapting to the needs of the market. What you also can see here is the different stages we have. So every core, if you worked in a commercial company, you know there are stage counts before you can get your IP or something like this. We are doing something similar, a little bit more light version. If you work in a company, you know how difficult it is to get everyone to agree when you can move forward to the next stage with your IP. So in open source, globally distributed with many, many companies participating, the tooling is a little bit more complicated, but we're still having a lightweight stage process that is really also important for the quality. Talking a little bit about statistics, how do we measure that our stuff is really cool? Because we believe it's cool, but do you believe it's cool? We thought actually our GitHub stats is a great way for this. So you can see we have a little bit over 1,600 forks. The numbers actually from summer this year, so it might be a little bit more. Yes, maybe not every fork is actively working or developing on it, but it's already a good indication how many people show active interest. There are also stars where people stare at it, over 4,000. If you compare this a little bit with other open hardware projects, that is really a great number and also shows the big interest. But now coming to the really cool stuff. That is where you see the RISC-V course, this open source course, going into real products. So for example, Silicon Labs here, they have in the beginning started with our embedded course. They used the CVE4, which is the RISC-V core from Pulp, and they have helped to bring it into production. As of today, there are 40 different silicon tapes out with it. We know the tape out rate is hundreds of millions from this course at least. And yeah, as Daniel put it from Silicon Labs, he said we really needed to have something power efficient, yet customizable, and very easy to deploy without all this legal stuff. Another cool project that is the CVA6, or Ariane formerly known. Here Thales is leading the integration. Thales really has pushed and helped a lot. Here as well we have over 40 tape outs in real silicon of this chip. The only thing here is we don't exactly know how many 100 millions are shipped. For the other ones, we know it quite good for the embedded cores, for the application processor. It's not so easy to get them. That's also part of our license. Yes, we are very permissive, so people don't need to report back how many they tape out. They just can take it. But it's always great when we hear from some of our partners, members, what is the current state of the union. All right, that was a short introduction. Sorry, maybe it took a little bit too long, but coming back to the real core of the talk today, what is our takeaway from this open source course? What did we learn when you're making an open source industrial grade core? The first thing is having a permissive license. You cannot go to a company, to an industry and say, we do have this GPL license and whatever you're changing, you need to give back to us. So that needs to be permissive. Otherwise, these companies just take all their patents and run away. If you want them to contribute, you need to have a permissive license. We went for the Apache license. It's one of the strongest licenses for permissive use. And as you also can see, there are various different questions on the web or trying to see this, capturing it, and the permissive license getting more and more. So the question is with the permissive license. Now the cursor don't want me. The question is with the permissive license, how can we get people actually to contribute? Nope, it's not working on the computer in here. Apologize for that. Nope. I have problems to move the slide on, so maybe while one of the technicians is coming, I just keep talking and you imagine the next slide. The next slide is actually a little bit boring. It has a lot of technical or a lot of wording on it, but the idea behind the permissive license is just that when you have this kind of license like Apache, companies they are not forced to contribute. So you need to find a sweet spot. You need to make something for them where they are saying, okay, that's what I like, and I take the license, I take the score, I integrate it, and I maybe find some bugs or something else. Also, today there are not many bugs left in the open core hardware. But yeah, you need to motivate them. You cannot force them by license to contribute. You really need to find something to show them that's the right thing to do for you. Then I will go to the next slide. So imagine the next slide is a very dark green. It's not fitting with all this white. And the next slide has a big logo from the FOSSI Foundation on it. Because what we did is in the next way, we said Apache is great, but it's more for the software related things. And then how can that fit with hardware? So on one hand, the course, the open hardware course, is a part of software, but later it will become hardware. And what this solder pad license is doing, what the FOSSI Foundation made, that is allowing you that you can then take the hardware, it's defining what is inside, and it makes it very easy for a lot of the companies because their legal guys, they know the Apache license, they see solder pad on top just defining some words or some different use case. So it's super easy to get this approved in a commercial environment. I'm sorry for the slides. We kind of lost them, but I keep talking on and give you an impression what will be next. So the next case is verification. That is the second lesson, actually, how to verify course. I always loved when Rick was presenting it because Rick was very visual about it. He said, if you're an engineer in a company, would you take your badge and bet it? Would you go in your boss's office, put the badge down and say, hey man, I found this open source core and it's really great. That's what we put in our next design. Nowadays, a design is something 10 million and higher upwards. You will not gamble that on an open source software. So from day one of the starting of the Open Hardware Group, one of our important things was to put the emphasis on making everything verified and everything trustable. The next slide would show you now some of the verification groups. So we have a verification group where we actually have industry members joining. We are making the test benches for all our cores open source on our GitHub, so you just can get it. It works with various different tools because every company uses different tools. There might be Siemens, there might be Synopsys or Cadence, there might be other things. And every company has a different setup, so our approach is trying to have as much different setups as possible. All right, so the first use case, it needs to be really permissive license. The second use case, it really needs to be verified, it needs to be flexible. And then the third use case, imagine I have a new slide on it which says third lesson learned. The third lesson is that you need to have an ecosystem. Having only a CPU core is already a great start, but you need to have the whole other thing around. That means you need to have compilers, you need to have a software development kit, maybe some real RTOS like FreeRTOS, Zephyr or something like this, Linux, Cypher, Yocto, Fedora, Red Hat. And that is also something we are providing. We are helping together with our members, creating various task groups for software, but also for compilers. So for example, some of the task groups are chaired by Ember Cosm, really great stuff. There are great compilers for our cores. We are working on we have an IDE which is based on the Eclipse IDE together with the Ember Cosm. So this ecosystem to make everything available is very important, but it doesn't stop with the software. You also need to have the second part to validate, to verify it, and that is like a FPGA platform. So this software groups also define the FPGA platform. You can take an off-the-shelf FPGA board, take our bitstream and just put it on it. We also put all the recipes in our GitHub, so you can go there and get it. That is really important to have it very easy and have all the things in one place. So that are the 3 lessons we have learned making this FPGA or this open source RISC-V course since a while now. The first thing is really permissive license, best something which the companies already know, like Apache in our case with solder pad on top. The second case is
to have this whole ecosystem or have it verified so people can trust, people can check your verification, can take the recipes, check it with their commercial tools to make sure there is nothing working. And then the third case is really to have an ecosystem. That's where we are inviting a lot of members, where we see a great interaction. For example, currently there is a acceleration interface, which we are kind of standardizing, and you see big companies like NXP, Thales, and Silicon Labs, and many more coming together and discussing openly what they would need in the specification, what should be in the next core. I think that is really where the collaboration is going, where we are going in future. So from the OpenHW Group, we now also have the next step. Remember the first slide I said with this announcement about the business wire. We are now bringing out some information or some platform where you can put on your software, test your software, but it's not only for OpenHW. We are actually going one step further. That is a vendor-neutral testing. You really can test and validate your course on the open source course from OpenHW and test if your software is working with the latest RISC specification, and have just kind of a golden model for this test. You can run it in Amazon Cloud, wherever you want. That brings me to the end of the talk. I'm really sorry about the slides, but I hope I could make it a little bit visual for you. The OpenHW Group has in the theater and the booth a really big booth, so please find us there. We also will have talks from our members talking about some new development we are working on, and just pass by, check us. Recently, we have taped out a microcontroller unit. I forgot to mention that. That's also important to see that the IP is silicon-proof. So come around, touch the microcontroller, see it's the real stuff. Ask us a ton of questions, how we verified it, how we taped it out with Global Foundries in 22FDX, for example. We're happy to take your questions. And now I'm not standing between you and lunch anymore. So thank you very much.
Let's give Florian a big hand.